Hey guys, we're going to do just a little homework help on dilations today. We talked about how dilations are how we make shapes larger or smaller, or um, how we enlarge them or reduce figures. All right. Um, Dilations always have a center, and this is the fixed point used for measurement when altering the size of the figure. For example, here in this quadrilateral, it says the center is going to be at A. So whenever we multiply all the dimensions by the scale factor of 2, A is going to stay right where it is. Right? And we did this in class. A stays there, and when we multiply the dimensions of AD is 2 long, so we'll multiply it by 2, the scale factor of 2, and it becomes 4. AB becomes 2 because it was 1, and then CD was 2, so D prime is out here, so it becomes 4. Right? And we just show that here is an enlargement by a scale factor of 2. Alright, and A stayed right where it's at. We talked about how when we have a coordinate grid, the center becomes the origin. Right? If they don't tell you where the center is the origin. And I explained how graphing dilations, when you're given ordered pairs, it's much easier, because really all we have to do is multiply every coordinate of the ordered pairs by the scale factor. See this one, it tells us the scale factor is 1/2, and they're showing here how we're multiplying each coordinate by 1/2. 3 times 1/2 is 3/2, or 1.5. Right? 8 times 1/2 is 4. Okay, and here was the original figure, a JKL, at the point that they have. J is at 3/8, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and then J prime is going to be at 3/2, or 1.54. So 1.5, 1, 2, 3, 4. Right? And you see how the origin stays where it's at, and it's the figure that moves. Right? So that is much easier. You can also tell here it gives, before we go on to what you can also tell, an enlargement is multiplying by a scale factor greater than 1. A reduction is multiplying by a scale factor less than 1 but greater than 0. You can also tell, you can look at an image and figure out what the scale factor was, right? You can do that by looking at the points. See, B is at 1, 2, 3, 4, 1, 2, 3. So B is at 4, 3. Well, B prime is at 1, 2, well, that wasn't a good one to do, okay? We don't know exactly where that is. I probably should have done A, but really you only need to do 1 to get what the scale factor is. A will do that. There's Mr. Reeser's mistake on YouTube, and it was negative also, so that was even better, a greater mistake. -1, -2, -3, and then -1, -2, -3. So -3, -3. Right? Then A prime is at -1, -2, -1, -2. All right, so we got to figure out, how do we get from -3 to -2? Right? And we kind of just think of how we found scale factors of shapes. Remember when we were dealing with shapes, and we had 2 shapes, and the corresponding sides, like one was 3 and the other one was 2. That would actually kind of be silly. Always believe the numbers, never believe the figures. 2, 3. All right, and I said that if you just pick corresponding sides and make that your scale factor, you'll have the right thing, right? So it's either 3 over 2 or 2 over 3. We can actually do the same thing with this, right? What would we multiply negative 3 by to get negative 2? Well, we're going from, this is actually smaller to a larger number, but we're going to forget about that right now because we can't multiply by a negative scale factor. But you can say, well, it'll be 2/3 or 3/2, right? And if we're forgetting about the negative sign there, how would we go to 3 to 2? We would multiply by something smaller, right? So 2/3. So negative 3 times 2 over 3, right? We'll put that over 1, and that's going to get us negative 6 over 3, which would be negative 2, right? Well, if that's how we get there, we can go ahead and do that with these other points and figure out where B actually is. This is negative something. It's negative 1, 2 something, right? So the original B is at negative 1, negative 2, negative 3, negative 4, and then 1, 2, 3. Negative 4, 3. Well, where's B prime? We're going to multiply this by 2/3. So negative 4 over 1 times 2 over 3. All right, negative 4 times 2 is negative 8. Over 3 times 1 is 3. So where is it at? Negative 8/3. 8 divided by 3, 2, and 2/3 left. So this is 2 2/3. Negative 2 2/3. Okay, because negative divided by a positive would be a negative. And then we'll do the same thing with 3. And what do we know we're going to get? We're going to get 2. Okay, and we would do the same thing with the other one there, with C. Okay, actually let's just do C. So this is at 1, 2, 3, 4, 5, negative 1, 2, 3. So C is at 5, negative 3. So where's C prime? So we're going to multiply 5 by 2/3. 5 times 2 is 10. 1 times 3 is 3. 10 divided by 3. 3 will go into 10 3 times with 1/3 remaining. So x is 3 1/3. Then the y coordinate, which is negative 3, will become negative 2. We've already done that math. Okay, and let's see if that's where it is. Go to 3 1/3, 1, 2, 3 1/3, then down 2. Absolutely. Okay, so there's an example of that. You actually had a couple of those on your homework. I can show you down here. They want to know what was the scale factor? You know, and then is this an enlargement or reduction? Now this part should be easy. Enlargement or reduction. You look. Well, what is it? We have. Let's see if that clears up a little bit. Focusing. There you go. These are just RST. Oh, this is R prime, S prime, T prime. So this was the original figure, and then this is our image. So if we went from small to large, it must have been an enlargement, right? So the homework, that part, we just did an example of that. Somebody had a good question about this one right here. They said, how do I figure out how long that is, you know, because I said that we're just going to multiply all the dimensions. Well, what we can do is we can actually make what they say the center is. Let me get my toolbar out. We're going to make what they say the center is, actually make that the origin of our coordinate grid. All right, I'll use blue here. We'll just draw a line. They say center is C, so we're going to make that the origin. Right? And we can actually put those points. Well, C is at 0, 0. So when we multiply those coordinates by 2, C prime stays 0, 0. Right? B, on the other hand, B is at 1, 2, 3, 1, 2. And we're going to multiply those by 2. So 3 times 2, B prime. 3 times 2 is 6. 2 times 2 is 4. All right, and then A is at 0, 1, 2, 3, 4. And then A prime, we're going to multiply those by 2, 0, 8. So, we can draw the image after dilation with the given scale factor by keeping the center at the origin, and we can make the lines there. So C prime, 0, 0. B prime 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Right. B prime, and then A prime is 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. A prime. And what we see is we have an image that's been enlarged by a scale factor of 2. Okay, with C. Now this one's the same thing, but maybe we would put, this is our N is our center, so N is going to be at the origin. All right, and so now our points, N is going to be 0, 0, but now we have to deal with some negatives here, and we're going to multiply it by 1/2. All right, so same thing there. Just looking at the back, I'm just going to pick a couple. I haven't really read them. Film with a width of 35 millimeters is projected onto a screen where the width is 5 meters. What is the scale factor of the enlargement? So the first thing we want to do, underline the question. All right, what is the scale factor of this enlargement? So we know it's going to be a number that's greater than 1 because it's an enlargement. Important information, right? The film width was 35 millimeters. That's important, right? And then the screen width is 5 meters. So we're going to have to do some converting here, right? I say we convert meters to millimeters. That just sounds easier to me. So I'm going to say 5 meters over 1, right? And then we're just going to do dimensional analysis, just simply because we just learned about that. And then we're going to multiply that. Meters goes on top. They were on top, they go to the bottom. And then millimeters is on top. And we know that 1 meter is 1,000 millimeters. So it went from 35 millimeters, the width, to 5,000. Because our meters cancel, we have millimeters left. Millimeters. Well, how did we get there? Right? How did we get from 35 to 5,000? We must have multiplied by something greater than 1. So I can say, well, what times 35 times, x, there you go, 35x. 35 times what number equals 5,000? Right? What do we have to do? We get x by itself. So divide by 35 on both sides. And then we get our calculator. And when I do that, all this is going to disappear. So I'm going to say 5,000 divided by 35. And there we go. That's our scale factor. And like I said, I would just go ahead and take that 142 point and then round to nearest hundredth, because that's usually what we go to if they don't tell us where. 86. Right? There's our scale factor. All right, so these are getting longer and longer by the minute. So I hope you have a good spring break. I'm sorry to have to give you homework over spring break, but it's not very hard. Hopefully you'll go home, get it done right away. That way, you're not on Sunday night thinking, oh no, I have to do this, or you don't forget about it. Have a great spring break.